This is MAC 1105, Section 1.6. This actually corresponds to Section 1.6a in MATLAB. And this is all about solving by factoring, which we learned in Section 1.5. We know everything has to be on one side in descending order equal to 0. So these will be very similar to what you did in 1.5. The difference is these are not specifically quadratic equations. These are higher powers. So we have to go over how to factor the higher power. So this should be a review of Algebra 2 for you. So everything on one side in descending order equal to 0 tells me I need to bring this 27x squared over here. So this is 3x to the fourth minus 27x squared equals 0. So everything's on one side, it's in descending order, it is equal to 0. And the first kind of factoring you're supposed to think about is taking out the GCF. So if you look here, the GCF between 3 and 27 is 3, and between x to the fourth and x squared, it is x squared. And if you factor 3x squared out of there, you are left with x squared minus 9 equals 0. Now we have taken out the GCF, but we have not completely factored this polynomial. So we will bring the 3x squared down. X squared minus 9 you should recognize as a special type of polynomial, and that is the difference of two squares, which will factor into x, a plus and a minus, and the square root of 9 is 3. That is the complete factorization of that polynomial. So we're going to set each of those equal to 0, which is what the zero products property tells me to do. And there is a shortcut, and we'll go over that in a second, but this is step by step right now. So if you set these each equal to 0 and solve them, of course if you divide this by 3, you still have x squared equal to 0, take the square root, and x is 0, which you don't have to go through all of that work. Anytime you have a GCF that's a monomial with a variable equal to 0, automatically 0 is one of the solutions. And these two you can just look at and see x equals -3 is one of the solutions and x equals 3 is another. On MATLAB, they'll have x equals, and in the box, you can enter them in whatever order. And there you go, 3 solutions for that. All right, we need everything on one side equal to 0, so keep the x cubed and the x squared here, bring 4x over, bring the 4 over, equal to 0. You want to look to see, is there a GCF? No, there is not a GCF for all 4 terms, but because there are 4 terms, you should think about grouping. And with grouping, you look at the first 2 terms, and you try to take a GCF of just those 2 terms, and the GCF for those 2 terms is x squared. And when you divide each of those by x squared, you get x plus 1, minus whatever the middle sign is on grouping comes down here. And the GCF for these two is 4, but technically it is -4. So I'm dividing both of those by -4. -4x divided by -4 is x. -4 divided by -4 is +1. At this point, if what you have in the parentheses is the same, that allows you to continue. I always bring that out front. It doesn't matter what order you put it in. I take that out front, and then what goes in the other parentheses will be those 2 terms. And like this one over here, we are not finished factoring. I can bring the x plus 1 down. X squared minus 4 is the difference of 2 squares like this was. So this is x plus something, x minus something, and that will be 2, 2. And you can just look at those terms and see that x equals -1, -2, and 2 are your solutions. This is very similar to the last problem, where we need to move everything over onto one side, and we generally move everything to the left side. But I would suggest on a problem like this that you look at that power right there, that's your highest power, and your lead coefficient is a +8. We would like to keep the lead coefficient being positive. So we're going to bring the 2x over this way, and bring the -3 over this way, and the 0's over here. Now, if that bothers you to have it on the right side, then you could just totally rewrite the problem as 8x cubed minus 12x squared minus 2x plus 3, and flop the 0 over there, and then it looks, I guess, normal if you want to say it that way. We want to look to see if there is a GCF all the way across the 4 terms, and no, there is not. So since there are 4 terms, the next thing you look for is grouping. For those two terms, the common factor is 4x squared. And if you divide 4x squared out of here and here, then what's left inside here is 2x minus 3. Minus, so you put the minus there, you look at the 2x plus 3 and think, wait a minute, there is no common factor, but we do have to have a common factor placeholder if you want to think about it that way. So this would have to be a 1. Actually, the common factor is negative 1. So if I divide each of those by negative 1, this is going to turn into 2x minus 3. Remember, to be able to complete the problem with grouping, what's in the parentheses must be the same thing. So I can bring the 2x minus 3 out front, and here I will have the 4x squared minus 1. And this is not totally factored because 4x squared minus 1 is the difference of two squares, just like we had on the last two problems. But it will be a 2x in each of the fronts, not just x. Plus 1 minus 1. Set each one equal to 0, or use the shortcut, which this is going to give me 3 halves. This gives me negative 1 half. This gives me positive 1 half. So to remind you what the shortcut is, it's just a matter of changing that sign. So negative 3 became positive 3, put it over that 2. So here, change that sign. 1 became negative 1, divided by 2. Same thing here. Now, let's review something that you had in Algebra 2 and Algebra 1, and that is how to factor the difference of two cubes. When you're going to do the difference of two cubes, I suggest you rewrite the first problem this way. What did you cube to get x cubed? X. What did you cube to get 8? 2. Once you have it in this form, then you can write your binomial. Remember, the difference or sum of two cubes is going to break into a binomial times a trinomial. And the binomial comes from this step right here, x minus 2. You must do 4 things to build your trinomial. So what those 4 things are is you're going to take this x and multiply it by itself. X times x is x squared. Change the sign. What sign am I talking about? That right there. If that's a minus, then this needs to become a plus. The next thing you do is multiply 2 times x, which gives us 2x. Plus, always plus at the end there. The last multiplication is 2 times 2. So these 4 things you are doing, that's a 4 there by the way, the 4 things you are doing are multiply x times itself, multiply 2 times x, multiply 2 times itself. So you can think about multiply, multiply, multiply. And just remember to change that sign. That last sign is always positive. So that is my factorization. You may look at that trinomial and think, oh, that should factor into 2 binomials. It's kind of suspicious. I'm thinking x, x, both plus, and now I'm down to what multiplies to give me 4 that adds to give me 2. There aren't any numbers. So even though it looks like it ought to be a good candidate to continue factoring, it does not. So at this point, we have our 2 factors to set equal to 0. X minus 2 equals 0, and x squared plus 2x plus 4 equals 0. Now this one's easy. That's just x equals 2. But this one, because it does not factor, we have to use the quadratic formula on that, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is 1, b is 2, and c is 4. So this is negative of b, so it's negative 2, plus or minus b, which is 2, squared, minus 4, times a, which is 1, times c, which is 4, all over 2 times a, which is 1. Now I have to squeeze this in here. This is negative 2, plus or minus. You can let your calculator do this arithmetic. Remember from section 1.5, you can enter all of this in your calculator, not the square root, just 2 squared minus 4 times 1 times 4, and that will give me negative 12 all over 2. And I then have to take care of the square root of the negative. So this is negative 2 plus or minus 2I radical 3 over 2. Remember, the square root of a negative is what gives me the I. The 2 radical 3 comes from doing a factor tree on 12, which you should be able to do. Last little thing is a triangle trick right there, because if there's a common factor of 2 here, here, and here, I can divide out by 2, and I'll go over here to put that answer. So 2 into negative 2 is negative 1. 2 into 2 is 1. Now 1 times I is I radical 3. And 2 divided by 2 is 1, and there's no reason to put that on the bottom. So those are my 2 solutions for that as well as that. So when you write your solutions, then you will have 2, comma, negative 1 plus I radical 3, negative 1 minus I radical 3. There are your 3 solutions. One more of these goes back to the beginning of this little video, and that is, let's get everything on one side and think about looking for a GCF, which the GCF is 2x, which leaves me with x cubed minus 512 equals 0. And you're thinking, wow, how do I factor that? Well, because that's x cubed minus something, you need to think about the difference of 2 cubes, just like we did a second ago. So we have the 2x coming on down. Let's just go over here out of the way of the rest of the problem and think about this being something cubed minus something cubed. If we can find that number right there, then we're going to be on our way for the difference of 2 cubes. Of course, what you cube to get x cubed is x. Now 512, you could use your calculator, the graphing calculator, and go to math. And under math, you will see this cube root. So you could type in the cube root of 512, and it gives you 8. So this is x cubed minus 8 cubed. And that right there is your binomial. So we've got our binomial, x minus 8. Then we must go through the steps to build our trinomial. Remember, multiply x times x, which is x squared. That sign is negative. We need to change that sign to positive. Then multiply 8 times x. Then multiply 8 times itself. And there is your total factorization. We can set 2x equal to 0. We can set x minus 8 equal to 0, and those are very simple to solve. And then x squared plus 8x plus 64 equal to 0. This is going to give me x equals 0. This one gives me x equals 8. And just like we said a little while ago on the last problem, you look at this trinomial and you think it ought to factor, but it does not. Anytime you do the difference or sum of 2 cubes, your trinomial does not factor any further. So go straight to the quadratic formula, negative 8 plus or minus 8 squared minus 4 times a, which is 1, times c, which is 64, all over 2 times a, which is 1. And this becomes negative 8 plus or minus the square root of negative 192 all over 2. And then what's left is to simplify this. So we've got negative 8 plus or minus. Of course, we're going to have to bring an I out, and this is 8I radical 3. I leave it to you to do the factor tree on 192. You can do that on your own. And the I came out because it was the square root of a negative all over 2. And we're going to do our factor or our triangle trick on this. Divide by 2. 2 into negative 8 is negative 4. 2 into 8 is 4. And 2 into 2 is 1. So that gives me negative 4 plus or minus 4i times the square root of 3. Now just be careful of one little thing. MathLab will ask you to list all of the solutions. Don't just list that red one. Your solutions are 0, 8, negative 4 plus 4i radical 3, and negative 4 minus 4i radical 3.